My name is Jovan Popovic, and I am Program Manager in SQL Server Group, working on JSON support in SQL Server 2016. In this session, we will see what is JSON and how we can use it in SQL Server. The question, why we have added JSON? The answer is simple, because JSON is everywhere. JSON is a popular format that is used for data exchange and system integration. If you look around, you can find JSON everywhere. Just take a look at your web pages with all JavaScript and JSON components that use JSON, or AJAX requests that are taking JSON from web servers. Web API, REST, or data services return JSON. Most of Azure services accept or return information formatted as JSON. NoSQL databases represent information as JSON in order to provide flexible models and the data structures that can be easily changed or extended. If you're working with IoT, you probably have a lot of sensors, cars, devices, or airplanes that are emitting telemetry in JSON format. You can find a lot of log files that are formatted as JSON. Whenever you see two systems that are exchanging data, probably you will find JSON. If you want to exchange information between the services and older versions of SQL Server, you might need to do some transformations in your code. Although there are some components, libraries, and frameworks that can parse JSON and read data from databases, format them as JSON, in many cases, you will need to add some additional logic and transformations. In some cases, you need to handle the fact that structure of your data is frequently changed over time, and that you cannot just add new columns or tables for every small change. In that case, you might wish to represent your data as JSON and get all flexibility that current NoSQL data stores give you. With new built-in JSON support in SQL Server 2016, you are able to simply load your JSON data into your database, read or modify values in your JSON documents, or export your tables as JSON. Your JSON documents can be stored in files, in standard tables, in-memory tables, column store indices, and you can query both JSON and relational columns with the standard SQL queries. So what we have in SQL Server 2016? If you have JSON documents stored in your tables, files, or sent from clients, you can use simple functions that read values from JSON, modify JSON documents, or check is JSON properly formatted. You can use these functions in any SQL query together with any other SQL function. If you want to do some complex processing or reporting on JSON data, you have a new OpenJSON function that transforms array of JSON objects into tabular format. Array will be transformed to table, JSON objects will be transformed into rows, and key value pairs will be transformed to columns and cells. Once you transform JSON to tabular format, you can run any SQL query on your dataset. Finally, if you want to export data from tables, you have new forJSON clause that takes your rows and cells from your result set and formats them as JSON. This was the short overview of functionalities. So let's see them in action now. In this demo, we will see how you can store JSON with other relational columns in SQL Server, how you can import data from files into SQL Server, and how you can export data from SQL Server into external components. Imagine that you need to create a table where you will store different products such as phones, laptops, toys, cars, furniture. If you want to model different types of products, you might end up with a wide table with a couple of hundreds of columns because you need to create a new column for every specific field in some product type. As an example, you'll need to add number of doors, memory size, hair course, etc. As an alternative, you might create some complex relational schema where you'll break product types in different tables. In some cases, you might wish to do something like in NoSQL database, where you can just put any custom field as JSON. JSON in SQL Server 2016 enables you to combine the best of both relational and NoSQL worlds and create the best model that fit your use cases. In this example, I'm using one simple table where I have only columns that are common for all product types, such as ID, name, or price. In most cases, I do need to have relationships between my products and other things like types, models, categories, manufacturers, etc. In SQL Server 2016, your JSON collections are not disconnected from other data tables. You can easily establish relationships between product collection and other relational tables. Therefore, I will add foreign keys like product model ID and product subcategory ID in my table. Finally, I need to model all other fields that are custom for each product type. For other fields, I will just use one JSON column where I will put all custom fields as key value pairs. If I run this query, I can see that I have product IDs, names, prices, foreign keys that are common for all product types. And in this JSON column, I have all custom fields like product numbers, make flag, number of doors, etc. With this structure, it is extremely easy to add any new field or structure in your data model. Just add any key value or any array or any complex structure in your data column. This way, I'm combining the best from relational NoSQL models. In SQL Server 2016, I have new JSON functions that I can use to read values from my JSON data. In this example, I'm returning name and price, and also color, standard cost, and class from JSON column. And I can also combine JSON values and standard columns in where clause. If I execute this query, I will get data both from standard columns and from JSON column. If I send results of this query to any tool, there will be no difference between information that are coming from standard columns and from JSON text. You can also modify any value in JSON text using JSON modify function. This way, you have the same experience while working with JSON data as with any other data. This example will just take this new value, write it into color field, so we can write it back into this data column. If you are concerned about the performance of your JSON queries, you can use the same indexes on JSON values that are used on standard relational columns. In this example, I will try to filter products by part number. I have an index that is created on this JSON value. So when I execute this query and look at execution plan, I will see that SQL Server has used non-clustered index. We have index seek operation instead of full table scan. This is the same technique that you use to optimize your queries with standard columns. Your JSON documents can be placed anywhere. As an example, you might have a plain text log file that contains JSON entries. I have one log file that is generated by some web application where we have information about pages, about time when some user accessed some page, duration, origin IP, name of the user. With new JSON functions, I can easily parse this information and transform it into tabular format. First, I can use standard open row set function to read all information from my file. Here, I can see all my JSONs shown as lines. Now, I can use my open JSON function to open each of these entries. I will just apply this open JSON function to every log entry and define what fields I want to get from JSON. Let's see the results. As you can see, although I had a plain JSON file, now I have standard tabular format. External tools like Power BI will not see any difference between JSON data and standard relational data. Therefore, I can just open Power BI, put this query as query in Power BI, where I can see all this information that we have here, like page, user, time, IP, duration. And then I can create any report with this data. As an example, I can create new pie chart, and I can put the page, and I can show duration. So this chart will show me total duration for each page in my web application. As you can see, with new JSON functions in SQL Server 2016, we can easily get data and show them in any reporting tool. The last example, you're probably creating some kind of web applications where you need to show data in some fancy jQuery components or other components. As an example, you might use D3 components for creating charts or GS3 component for creating trees. Now you know that you have information in your database. Now question is how you can get your data from your tables and show them here on your jQuery components. In this example, I have one simple table, employee, with columns ID, name, and manager ID. Now, if I want to show this information in my GS3 component, I can just execute this query and add for JSON path. For JSON path will just format results as JSON, so I can see it in new window. Now, what can I do? I can just go to this JS3 component, HTML source of my JS3 file, and here I will replace JSON source that is used in default example with my data source. Now let's save this file and see results. So as you can see, my entire organizational structure is shown in this tree map. I just need one for JSON query clause just to format my entire SQL table into JSON. Now let's see another example. Here I have one D3 chart that is used to show some series and groups in the web page. I can easily switch between grouped and stacked style. Now the question is, can I take some SQL Server query and just show it on my chart? So here I have some SQL Server query that returns some information. What we'll do is I will add for JSON auto clause, and for JSON auto will just format results as JSON. I can see it in this page. I can copy everything. Now I can go to source of this HTML page and replace original JSON with the JSON that I have generated from my SQL Server database. Now, when I go back to this page, can just refresh results. And here I have a web chart with all information from my SQL Server database. So as you can see, it is extremely easy just to get some SQL Server result, format them as JSON, and show them either on jQuery components or D3 components. You can return these results as responses of web services, send them to some AngularJS application, React.js, or any other application that accepts JSON. So whenever you need to get some JSON data into your database, transfer your data to some external components, or create flexible schema, think about SQL Server 2016 and think about JSON. It will make your life easier. If you want to know more about JSON functionalities in SQL Server 2016, here are our official documentation and blog posts where we are publishing various scenarios, tips, and tricks that can help you. So download SQL Server 2016 now, try new JSON functionalities, and let us know what you think about this. Thanks for watching, and I hope that you liked this session.